Welcome to today's class where we would be dealing with Starknet scaffold, just like a brief introduction to it, before we go to the core focus of the class, which is substreams, and how to properly implement substreams on Starknet. So substreams or subgraph, right? So what makes the subgraphs on Starknet different is that for the subgraphs on Starknet, you'd have to, first of all, create a substream. Then you can now choose to either sync that substream into a SQL database or to sync it into a regular subgraph, right? So by syncing, it's like you're taking the mappings that have been created and then you are syncing it into, you are creating a channel where it can be accessed, where there will be an endpoint and where you can make queries and stuff like that, right? If you notice, I said we are syncing the substream either to an SQL database or to a subgraph, right? You know, your SQL database, you'd make SQL queries, right? You make SQL queries to it. But if you are syncing it to a subgraph, you'd be making what? GraphQL queries. And another thing that makes this thing different from like the regular subgraphs is that unlike regular subgraphs where CodeGen is able to like generate a certain amount of code for you, with the subgraphs on Starknet, you'd have to define your mappings yourself. And you'd also define your schema by yourself, right? Which makes it different. But for now, let's just walk through how the Starknet scaffold works. Pretty much what the scaffold is that like they've created templates on how to easily deploy apps, right? So they have a couple of templates that you can easily use. It does all the whole scaffolding for you. Like, you know what the word scaffold means, right? Scaffold is like when you have something that is set in place to just make your work easier for you. So prerequisites, it kind of requires you to have your Node.js installed, your Docker, which is like a very, very integral part, right? You need to have your Docker installed, your code editor, either you're using VS Code Cursor, or you might be using Vim, who knows? Then your dev container extension. So for you to install it, you do npx create stack. So we would not, because this is not the focus of the class, I'm going to share like a link to this resource so that you could like go and work on it yourself. But then you'd want to create should we do this? No, it's going to take too much time and we want as much time as we can for us to be able to focus on the substreams. So you create your project with your scaffold and it usually comes with, so it will have like the front end, the DevNet and your contract. Everything has already been set up for you, right? So what you now want to do is that you'd want to either modify the contracts that are there, and then you can also like modify the front end a little bit, right? This makes your work 10 times easier, and you can also use it to like demo what your contracts have, right? You just want to demo all the functions in your contract beforehand, so you just want to go through it. Then one of the things that I'd recommend you guys do, can we give homeworks in this class? Yeah. So some people are saying yes, and some people are saying, but like we'll go with the yes, right? So one of the things I would encourage everyone to do is everyone should go through this speedrun stack, right? Things like this, they give you, it's like, as a developer, you are increasing your net, right? Your tools and what you have, right? So you have experience building a couple of this stuff, right? You want to try out their simple NFT example where you build like an NFT marketplace of some sort, and there's also a decentralized staking. So challenges like this are very good. They help you, they make you become a better developer because you'd have more experience, right? There are a couple of steps you'd follow, and if you follow the steps, you'd be able to like get everything up and running. But then note that you need to have Docker installed to work with this scaffold stack. It's important you have Docker installed and you have your Docker running. Because when you clone the repo, they would ask you to ensure that do you want to run it inside the dev container? You have to run it in that dev container. If you don't, you'll keep on running into errors, right? So we'll share the link to this, the speedrunstack.com, and also these documents where you can follow to create your project with Starknet scaffold. So now, are you guys ready for substreams? Let's get into substreams. So I asked at the beginning of the class if the counter contract that you created during the last class, does it have events in it? Are events emitted? Okay, so can someone show me the Okay. Okay. Give me the GitHub. This thing, let me just type it. GitHub.com. No, this is the wrong one. I need the right one. Community. Because I have one here. Okay, Discord is not on this my laptop, so I have Discord, but I don't want to open it, so yeah. Okay. So, right, so I want us to look at the contract so that we would see, this is it, right, events. Okay, I just want to look at the events that they have. So, we'll have a slight problem, right? So currently, the way the subgraphs on Starknet works is if you have an unsigned integer that is greater than U64, you will be having errors, right? U64. So the reason why it's having errors is that in their types, they only define up until U64, right? And if you want to typecast down from U128 to U64, what will happen? No, there will be what? There's what? You said it. Overflow, underflow, right? Because it's like you're carrying something that is very large and you want to condense it into something small. If you try to do that, you'd be having like an underflow, right? So what I would like someone to do is, you see these events, if we could just modify the parts that have U128 and convert it to U64. Can we do that? So that it would have, so that our amount would be, so this amount here will be U64. Can you guys do it? Clone the repo, modify the events. So instead of U128 now, it will be U64. And let me just look through the code so that I will see if right? So we'll be modifying everywhere there is a U128, we'll modify it to what? U64. So or should I do it? Because the way you guys are looking at me like as if I should do it. Okay, so okay. So now we'll just so we'll check out into that branch was SN Forge, right? So now we're there. Let's come back here. So one of the reasons why I don't want to do it with my laptop is So everywhere that is U128 now, I'm converting it to what? Right? Yeah. So we have to go and change it from there.
Hello, Gamuta. Ya, ya aiki. Gode wa Allah. Kan gode wa Allah yana.
Right? So we would now do what? Okay, so now we've been able to build it. So because what I'm considering now is how we are going to populate it with data, right? So we'll just deploy it and everybody would like interact with it so that we'll just have data inside, right? Yeah, before we now go about creating our substream. I mean, I could also decide to create a new branch, right? And call. Then we'll call that branch like Subgraph yeah, so branch Subgraph implementation, right? Then we can check out to it, right? That was a very poor commit format. You should have used something like, but no problem. So what do we call this branch again? Subgraph. Right. I don't know if I even have. Okay. So now we have the new branch. So now for the deployment, I had a document I was using as my guide. Trying to remember. Yes. I've already funded this account. You said? Okay. They might have. Could somebody deploy this on their end? I've already pushed this thing. So you deploy it and just give us the contract address. So while he's deploying the contract, I just want us to go through the documentation and read about what like substreams are and what subgraphs are. So if we go to TheGraph.com. So just so I'm not just like building off the previous class, right? I will just talk briefly about what the graph is. So for people who are like just coming to know about what the graph is, right? What the graph does is that the graph is used to index blockchains, right? And when I say index, what do I mean? I mean, because you are sending so much data to the blockchain when you have a dApp running, right? Because you are sending so much data to the blockchain when you have a dApp running, this means that you cannot be querying continuously. You cannot be doing continuous read queries because things like that will now be too stressful and too burdensome on whatever API you are using, right? Whatever node this thing you are using. So what the graph does is that it indexes this blockchain and it's able to aggregate this data, store them somewhere, and you can make quick fetch, right? You can be able to make quick fetches from that data point. So one of the ways that people do is that you're able to index all the events, right? You guys have already talked about events. And you know that event is a way of you to log data, right? So what the graph is now doing is that the graph is now in the middle, right? It's listening to your, it's like you put a, what would I say? You put like a stethoscope on your contract that you deployed, saying whenever this event is emitted, listen to it, right? Carry it and store it somewhere. So it does this process continuously and it's always active, right? There's no downtime. It's always monitoring it continuously, right? It's possible for you to now modify your settings and be like, okay, after so blocks, don't do this. But like that's like later on, right? But what the graph does basically is that you are indexing the blockchain and you are storing this data down. You get? So with this, you are able to have events that are being logged and you're able to like store them somewhere and retrieve them at any point in time. What makes this thing useful is, let's say for example, you go to, have you ever been to a dApp where you just see, yes, a good example. If you were on the previous version of Only Dust, right? You notice that when you come into the platform, they'll say so person just received so rewards. I don't know, did you used to notice it? You used to notice it. It shows so person just received so rewards. So person just received so rewards, right? So I mean, it's very possible that they built a system around it where they are always emitting an event whenever there is a payout, right? And you're always emitting an event whenever there is a payout. You could just have your subgraph that is running in the middle that is monitoring whenever there is a payout. So whenever there is a payout, it carries that data, it logs it down. Then they now have on their front end where they are just querying that thing and they are receiving it in real time, right? Do you see how seamless that is? Another example would also be, let's say for example, when you're looking at explorers, right? You could say, no, you won't say that. I'm trying to look for more practical applications. Another good application is, so you know, whenever you have a write function, right? A write function on your smart contract, it's not really ideal for you to return something after you've performed the write operation, right? So what you normally do when you perform a write operation is that you'd want to emit an event to inform that, oh, something has happened, right? So that means that for every state changing function that you have that is emitting an event, you could always update your app based on that change immediately without having to read the data of the blockchain. Do you get? So you don't have to be performing consistent read operations when you can just be listening to all the events that have been logged out. Do you get it? So you don't know that you will now be writing, let's say you have change state, let's say you have add number. So every time you do add number plus 1, you now quickly go read number. Do you get? It's stressful and it's cumbersome. But if you just listen to all the events that are being emitted, every time add number is being created, right? Just imagine you have a dApp now, right? And you have 1 million users coming to click add number. So does that mean your app will now be making how many read calls? Another 1,000 read calls for it to be reading the number that have been created. But if you just have something that has been logging all the events, storing them somewhere, it's just one query and it is constantly updating this thing. It's faster. is going to solve that problem that you're having, right? So one thing you can do, pending when we are getting this thing ready, is that you could edit your counter contract to have events in it, right? So that when we are done, you can be able to like, implement it also in your counter contract. Does that work? So now, yeah.
Now the subgraph acts as a middleman between the user and the blockchain.
Yeah, you can say it that way.
But
Or
just mention of write function. So I write it to the blockchain.
yeah.
Write it to the subgraph now.
So if you are writing to the blockchain, you are not passing through the subgraph, right? The subgraph is only there to listen to events that are being emitted on your contract. Do you get that? So what the subgraph is doing is, the subgraph is just an amebo, or sorry, an eavesdropper, right? Okay. What it's doing is that it's eavesdropping on your smart contract, and it is always informing the whatever system you've set, yeah, that so thing just happened, so thing just happened, right? So it's just there, it's constant, it's monitoring.
Okay, that means monitoring both that and the smart.
It's monitoring only the smart contract, only the events that are being emitted on the smart contract. Right. Yes. Okay. So now, because in like the previous blockchain class, we did the like subgraphs where we did with like a normal, a regular smart contract class, an EVM smart contract. So now, what we are going to be doing is substreams, right? So because regular subgraphs, you cannot just initialize them for Starknet, right? Because Starknet, they are like Rust-based this thing, right? So for substreams now, it's different, right? For us to implement these substreams, so if you come to the substreams doc and you come to Starknet, right, the Starknet section of it, you'd see that there is a dev container, right? So there are two ways that you could go about to initialize your substreams on Starknet. So remember the process I said, right? That we'd have a substream first, then we'd sync the data from that substream into what? Our subgraph or into a SQL database, right? So for you to initialize your substream project, right, there are two ways you could go about it. So for starters, what you want to do is you could either use the dev container, right? The dev container is making use of Docker, which means they already have like a set of files that are going to just make everything run because that's how like their environment is already set. Or you could go and install the Substream CLI on your laptop, which is what I did. So for you to install the Substream CLI, yeah, instead of Docker. So you could follow the documentation here on how to install the Substream CLI. So it's easy for people that are using Mac because like there's a simple homebrew installation. But I don't know if you have homebrew installed on, yes, there's homebrew. Yes, that's what I wanted to confirm. So you could just do this, right? Install streaming fast /tab/substreams. The Docker process is strenuous and like I just feel like it's better use this one. So you'd want to do this command, which is brew install streaming fast /tab/substream. So you just copy the command. Are you guys here on the documentation with me? Or should I send a link? I don't know, let me send a link to the documentation on the Meet. Right? So this is the first command. We'll be installing this, right? If you've installed it, let me also copy it. I mean, it's already installed on my laptop, but like, let's, right? So I'm thinking should I create a new branch on this? I mean, yeah, I'll create it here. So when you install it like this, I mean, okay. So who has installed it? this is the command here. Brew install. How far with the deploying of the smart contract? I think deployed it. You've deployed it, right? No. Okay. That's, you cloned down my branch, right?
Yeah.
Okay. So if you've installed it, what we'll do next is we'll do substreams -- version so that we'll know that it's installed, right? You could also do substreams. Yeah, substreams -- version to know the version. I think we need that. We need it now. What's the hassle? Okay. Is it from the contract? So with substreams, right, there are, where are we? So with substreams, that's the Starknet substreams, there are two types, right? When you want to initialize your project, there's the Starknet minimal. And what this one does is that it is extracting the raw block data, which that's pretty, what's the word? Open-ended, right? It's like you're extracting the whole block data and you're now trying to like map what you want from that block data, right? That one is the Starknet minimal. But then the Starknet events are much more niched because with that one, you're able to create substream that extracts and decode a specific Starknet event and calls, right? And you are filtering it by your smart contract address, right? So you provide your smart contract address, it will retrieve your ABI, and with that, you'd be able to like, you know, index your key events, right? One of the things that we are going to even focus on in this class is writing the schema and also writing the mappings, right? Because if you have to define the schema, right? And you also have to define the mappings, right? When it comes to, you have to get those two things right so that it will not throw error. Because you find out that if you not do these two things well, you keep on running into errors. The build will keep on failing. The deploy will also keep on failing, right? And the process goes like this. You write a schema, you generate the code. So you use CodeGen to generate the code so that it will generate the types that can now be imported into what? The mapping, right? Once you've done those two things, then you can now write the code. So it will now be like, you've gotten the data now. What do you want to do to the data? Do you want to edit it, modify it, before you now log it out to your subgraph? Do you get? So I need that contract address now so that we can move on. I would have deployed on my end, but like my environment has some troubles. The ones I told you about. Did anybody else try to deploy it? Did you try to deploy it? Oh, you are still downloading Substreams. Are you still downloading Substreams? Okay. Are you downloading Substreams? Okay. You've installed it. You've done Substreams version and it's working. Okay. Has anybody else installed it? Have you installed it? Usman, have you installed it? Okay. What's the update? Team deploy. What's the update? Let me see. I don't want to. I mean, maybe I'll just fund one of my. I know where this problem is coming from. Let me just fund it on my end. Okay, so I want to deploy it. So I want to try and deploy the contract on my end here. So you've deployed it. Okay. Was it the same error you were facing?
I was having this error, then I had to create new project and just move everything.
Okay. So can you send me the contract address? Do you have me on Telegram? Okay. Just how can you send it to me now? That will make sense. Just send it to me. Send it to me on Telegram. Just search Otaiki, Otaiki, on Telegram. I'll copy it and I'll paste it here. IKI. Have you seen me? Have you sent it? There's an anime icon. Yes. Have you sent it? What's the profile icon? Huh? Yeah. So that I'll just, because I want us to try and interact with the contract so that we would populate some data into it before we index it, right? So that by that time it will have emitted some events, then we can now index it and go through those events. Have you sent it? Yep, I've seen it. Copy link. So, right, so now we can look at the contract, right? If you come here, you see that no event has been called. This is the read, this is the write. So in the write, can we add a name? This is what I was worried about. I did not want us to have this kind of issue where you want to pass in something, first populate it. Let me see what I'll do to
You couldn't just make it fast. It run down totally.
You said?
I was having the same issue because yesterday after the contract.
When you try to interact with it on the scan, you find out that you're not able to interact with it properly. Yeah. So this is where that our scaffold stack would have been very useful. Because what we would have just done now is for us to just carry the contract, put it there, and just work with their setup, you understand? So that will be able to populate the contracts better, you understand? This is one of the reasons why I feared. And I don't want us to use a contract that has already been deployed. We can use that one, because that one would save us the stress of having to like populate it with data, you get. But let's see what we can do. The problem is, for it to be able to pass this stuff, right? Because it's byte array, it's expecting byte array as input. But whenever we pass in something, like, it's not able to, yeah.
I think you can actually use stack utils.
Yes.
Stack utils, yeah.
Yeah, so use stack utils.
So, if I should use this Starknet React, like when they have this code something, will that be able to handle this?
Yes, because what you do is that you want to convert whatever input you are getting. You know, if you are getting string, you want to convert that string to byte array. Like you can see now in this, what are we saying? In this stack utils now, when we pass in an input, right, it will give you its value in byte array, it will give you the value in string, you understand? It will give you the value as whatever you want it to be. But let me just put tester like this. So in byte array, we'll have something like this.
So now when you are fetching, is it going to return the string or the byte array? If you are fetching data, is it going to return a string in your contract?
So you know, if you are returning byte array, you'd have to convert it to a string on your front end. Starknet React is already doing the work for you. Most of all this scaffolding, they are already doing the work for you. But if you are using raw Starknet JS, you are the one that is going to have to write it yourself, you understand? And now the point is, there are some projects that you are doing that you'd have to use the raw Starknet JS. Like if you try to add it with Starknet React, it will be causing some kind of conflict, right? But most times, most of the projects that you are going to do, you'll just be using
So the byte array, are we to copy those three values or?
So we are going to do it together. Let's do it. But I think you are supposed to pass in the 3. So it will now be like 0, comma, followed by the next one. Or is it because I changed it from hex? Invalid. Let me convert it back to hex. Something like this. Unknown CUDA core. We have to figure out the best way to populate this thing now. Another thing we can just do is that we can modify the contract, right? We'll modify the contract to not collect byte array, then we'll redeploy it, right? So now it will be collecting string or felt. Felt is even better, right? Can we do that? Can you do that on your end, sharp? So you modify it to string, then, or felt rather. So now it's collecting felt as if, but you know that you also have to modify the places where you are storing it as well as the interface. And if we're emitting it, then we also have to change that too. Let me look at the code. Because on the front end, if you string, Are you converting it to string? Are you still typecasting the thing to string? And you're testing it on Voyager? Okay. Did you use the stack utils to convert it to felt? Because let's see what it's giving you. The felt to come as number, not this thing. Oh no. You'd have to, because I think even Starknet.js has some functions like that you can use to convert. Yes. So you'd get, if you go under the namespaces category, you pick the namespace that you want, then it provides you with like available functions that you can use. Right. My deploys are just having problem. I don't know why. Maybe it's because I did not do scap build first. Are you deploying now? Have you deployed? Please send Adi address. So this is the new address. So let's go. So we've created an account, ba? Yeah, but like, why am I not seeing? I hardly ever use this stack scan. I mostly use Voyager. So you can see 2 events, ba? Account created. So I think we should play around with some things. So after we've done this, we want to deposit, right? So let's deposit like 300, ba? Still not stressful. So I wait for this. It's taking time. But I guess other people can also be interacting with the contract, right?
Yeah.
Maybe you post the address on the Discord so that everybody will be interacting with it. So that we will have like a lot of events, right?
Okay.
So now, while we're getting the thing, while we're adding more events, what I want to do now is to start creating the substream, right? So we only need 2 events. That means the only place that event is being emitted is in this account. It's supposed to emit deposit made. So people will just be creating more this thing, right? So now, I'll copy this address because we're going to be using this address, right? So if you've installed your substreams, let me do this. Let me commit this code, all the changes that we made, right? Right, so now we want to go about the substreams, how to initialize it. So for you to initialize your substreams, you use substreams init, right? I remember I talked about like the 2 different types of substreams you can initialize. Either you initialize the Starknet minimal or the events, right? The events are the ones that are like, you are focusing on a particular address. Minimal focus on like the whole, it's weird that they are calling it Starknet minimal if you are going to be reading the whole block, right? But like the events are the ones that cover. So let's do substreams init, right? Remember, the command is substreams, not substream. And you must have installed it using brew. But if you follow the documentation and you find like another way to install it. Let me share I'm supposed to also share this documentation for the people on the chat so that they could also, okay, I've already shared it. So now we are going to do the substreams init. Let me clear this screen. Right, so I'll do substreams what? Init, right? So when you do substreams init, this is the first thing you'll see. You'll be asked to choose the protocol you want to work with. Are you using Solana, EVM, Cosmos, Starknet, or Stellar, right? Since we're using Starknet, we'll go with Starknet, right? So you remember I talked about the 2 types where there is the events beta and there is the minimal, right? Minimal indexes the full Starknet block, whereas events beta only does what? When you select a specific event and you create your substreams as your source. So we'll go with the events beta. So we'll put the name of our project. In this case, it's what? Simple what? Simple bank. Identifiers are only lowercase letters, blah, blah, blah. So we'll do a simple underscore what? Bank. So it's on the what? Starknet testnet. So you put in the address. The address of the contract we deployed. So let me also drop this for the people on the chat in case they are following along. Here. Right? Remember, please, you should be populating the contract for us. Yeah, ABBA, nice. I'm seeing a couple of events. I'll just copy that. I'll copy the address, and after I've copied the address, I'll come and paste it here, right? 676, right? I mean 6F6, so we are in the clear. F6, F6, F6. So now I'll press enter. Oh, error sending message, unknown right envelope. Let's do this again, right? Right, so I cleared this. Right? So it will fetch the ABI for me. And it's asking me, do I want to proceed with the ABI? Which we want to. Then the initial block number. So for this initial block number, you're going to provide the block in which the contract was deployed, right? You can do that, or you can also provide the block of the first event. Do you get? So we can just come here, we can look, you can see the first block is what? 715842, right? Let's come here. We want to find the block where it was deployed, right? Which is what? 715839, right? So let's use 715 what? 839. Choose a short name for the contract address. Lowercase and numbers only. So I'll still use what? Simple bank, right? Add another contract, no. In what directory do I want to do it? So because, you know, that directory we are using, it has a contract already there. So I'll do simple bank underscore what? No. Simple bank underscore, I can put graph, right? So now, by the time you've done this, if you come to your code, you see files like this, right? You enter inside. Can you see it? Are you seeing that it has initialized this simple underscore bank underscore graph? Am I moving too fast? Okay. How many people have initialized their substream? How far? But you've installed it on your laptop. Okay. Have you installed it on your laptop? Diane, have you installed it? Okay, your installation is still taking time. But are you following along? Okay. Guys at the back, are you guys following along? Okay. So now we're going to move on. So now we'll have like these files that are here, right? If you come inside, you just want to like check it, you'd see that there is a lib.rs, and this is written in Rust, right? If you understand a bit of Rust code, you understand that what they are doing is that they are looking at all the events that are here, and they are like sorting through it, you understand, and like creating kind of a way that you can be able to like query them, right? So because one thing with these substreams now is that you can even run a stream and you can be visualizing your data that is coming in per block with substreams. Substreams on their own, they are like insanely fast because substreams are written in Rust, which gives them like this crazy speed, you get? Substreams are like super fast, but we can now sync it, we'll sync it to a language that we can understand and we can write queries for, right? Because it's easier for you to write your queries in GraphQL. So that's why we are going to sync it into a subgraph. It's like we carry this thing, we'll come, they'll generate a file. There's a file that is going to be generated called something.spkg. That's like the substreams package. So it's from that substreams package, it is getting like the model it is using to create our subgraph. Are you guys getting it? It's somehow abstract, but like when you do it, you now see it in action, right? So now, immediately after you've initialized your substream, right? The next thing you want to do is to build it, right? So you could, so because there are two ways, either you decide to sync to a subgraph or you build on your substream, then you just sync it, you understand? So it's possible for you to define your schema and your mappings in this substream without syncing to your subgraph, right? But for our approach for today is that we are going to sync to subgraph, then write our schema and our mappings in the subgraph. Do you guys get that? So now we are going to build our substreams. You do substreams build. Oh, sorry, I'm in the wrong directory, right? Because we built our substream in where? Inside our folder, so we'll cd into it. graph, right?
Yeah.
So now we can now do what our substreams was build. This will take time, like it's going to take time, but by the time it has built it, let's wait. In the meantime, how you have initialized, right?
Well, why was you making of this subgraph?
Okay, you still want to know why we are using subgraphs.
Yes, kind of.
So you notice how in this, let me open this contract again, right? You see in this contract that we have here, we have this contract that we are indexing. We have events that are being logged out, right? These events now, this transfer event and this contract deployed, we can use it to be updating our front end seamlessly without having to be performing read operations to our smart contract.
Okay, fine, but there are some code base we go to see a file called what indexer.
Yeah. So now those guys that are creating files called indexers, they are not using Subgraph. So they are most likely using Apibara. Do you know Apibara? It's also an indexing solution. But now the problem with those indexing solutions is that you'd create an indexer, then you now create a normal SQL database, right? Either you use SQL or use Superbase. Because with Apibara, you still have to create a database with Superbase or with SQL, right? That you now write functions in your indexer that the moment your indexer is, so what's your indexer doing basically? Still the same thing, it's just monitoring for events. So you're now saying, anytime you monitor for events, write it into this Superbase directory. And in the end, what are you still doing? You are now carrying a Web 2 approach, right? Because you are writing to Superbase, which is a Web 2 this thing, or SQL, which is a Web 2 technology, and you are now fetching from that database. So now you are doing Web 2 data fetching, right? What happens if your Superbase database crash, right? Or what happens if, what can happen?
So, can they not use no SQL database
for
the indexing of the events? Yes.
Because now with this GraphQL, it's like you are even abstracted. You are saved from having to like do the whole creating of the database and all those things. You are not doing any of those stress. So. All what you are doing now is that you are making queries to the subgraph that has been generated for you with Subgraph, right? So it's just like Subgraph has helped you to do indexer. They've created the indexer for you. They've created the database where the list will be stored. And they are just providing you with the queries that you use to fetch your data. There is even a playground for you to visualize what you want to index. You understand? I've seen code bases that are using indexer like that, right? But then I just feel like graphs have been here for way longer and they have already sorted out most of the problems that you'd face, right? Look at the time we're going to use to initialize this thing. Then compare it with the time that you would use to do your, we're just talking, that's why it's taking time.
I saw that you were editing the smart contract.
To fit in with that U64, right?
So, what have I done with that? What are you now going to do?
Okay, so because like if you go through the types currently present in the graph, you find out that it's only available, so they are handling big integers up until U64. They are not handling higher than U64, right? And maybe one of the reasons for this is probably because the adoptions of subgraphs on Starknet is not much, right? The more people are there, then that means they'll be able to create a higher level of support. You get?
So now, if your smart contract now will accept more, just like some of byte array entry, Subgraph is not the best for you.
No, Subgraph can handle byte array. Subgraph handles byte array, it handles string, it handles even felt. And the process of converting the data for felt is even easier because they have an inbuilt method. When you just do dot to string, it converts that felt to string. You understand? Which is easier. I mean, the technology doesn't really matter, right? What matters in the end is, are you able to make the dApp work? So you could decide to use Subgraph, you could use Apibara, you could use DeepDop, you could use, what's the name of this one? There's this other guys. Yeah. So this limitation is just currently with this. So, I mean, there could be ways that we could go around it to solve it. But because I've not explored that yet, so I can't really see. But one way that I was theorizing that I could do it was that I could convert the big int that is coming in to a string, then return it as a string, then do the conversion in the front end. You see, that's another way that I can do it, right? But I was afraid that what will happen if maybe there is like a loss in like one of the numbers and I don't know, right? So that was why I just stopped there and I said, okay, let me just limit it to just use 64, right? So that means there might be more support for higher integers, but like I've not explored that yet. But I still feel subgraphs are like one of the easiest way for you to index your smart contract. Yeah. Yes. So that limitation is a limitation that I've not fully explored yet. You understand? So it's not like I see they wrote it in their documentation that this is the limitation. It's a limitation that I've not fully explored. That's why I just said it, based on what I've observed. But I think I'll even raise the problem on their Discord server because they respond very fast on their Discord. So I could raise it and be like, hi, I noticed, yada, 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 and I'll probably get a response from them. So
this one now, we deploy the contract at first because of not using the right array, then we have to convert the first.
yes,
So in the case of that, we have to use byte array
yes.
because we can't be restricted to the
So now, the byte array now, it's not, the byte array problem that we are having, it's not dealing with subgraph, you get, right?
Yeah.
It's because we wanted to populate data into our smart contract. Do you get? If we had built a front end, passing in that byte array to our smart contract is easy, right? Because we'll just use one of the utils function to convert it. But because we are copying and pasting on Voyager, so the data structure might be affected a little bit. We don't know the right structure to use. We don't know if we are supposed to use, what do they call this? We don't know if we are supposed to use square brackets, or we are to use curly braces, or we are supposed to use commas, or that. You understand? So that problem is, we have not sorted it out. That was why we just decided to migrate this thing. It doesn't mean that something was wrong. The only issue, which I mentioned, I observed, was the fact that it's not handling integers higher than U64. And that was, so I feel like maybe if I do more research, I'll be able to see something that might mean that. Because, I mean, U256 is a common data type in smart contracts. So it will not make sense for them to not be handling U256. So now that our substreams have built, we are going to go to the next part, which is what? Substreams auth. So this is just to authenticate, right? To authenticate on their end. So when you do substreams auth, it will give you this link. You copy the link and you can just paste it in your browser. Right? So when you paste it on your browser, okay, you'd have to log in, right? So me, I normally just log in with my GitHub. Right? So it will give you this token. And then you copy the token.
Okay.
Copy the token. Right? And we'll paste the token here. And we'll press enter. So now it has added our, it has authenticated it for us, right? So now it's able to like sync that, oh, this is the person that is this. Because one thing now with Subgraph and Substreams is that you can create a subgraph for a particular contract address, then you publish it. And when you publish it, you can choose to like either make it private or public. Other people can now be using that your endpoint to make queries. Because since all the data on the blockchain is public, right? If I index Uniswap, instead of you having to go and index Uniswap again, you could just use the endpoint I'm providing, right? And you'll be able to like make your queries, right? But then another thing you should note with the graph is that at a specific point in time, you'd have to use their tokens to make more queries, right? Because if they're giving you access to this thing for free, with time, you'd have to like pay. And they have their native token, GRT, which you can use. So now that we've authenticated, we'll do Substreams GUI, right? Substreams GUI. And yeah. So now when you press enter, it will start running a string. It will now like read from all the blocks to like monitor all the events that have happened. Are you seeing? Do you see that event? The account created on uncreated, and I think when you press P, you're able to move down. Are you seeing deposit made? Current blocks. Are you seeing it? Somebody created the account again. Are you seeing it? See how seamless it is.
But you see that the Subgraph have a inbuilt database.
Yes.
What I don't want to make use of it?
That's if you don't want to make use of the subgraphs. Yes, that's why it's possible for you to sync this data from your substreams into a SQL database. That's into your own database, which is SQL.
What about
No SQL. So I did not see that in the documentation, so I'll assume that like there is no support for that. For no SQL. I don't think there's support for no SQL.
Can I the results from this molecular query, can I go with that? Can I sync it
Directly.
yes.
Yes, that's why you can sync it to a SQL database.
Without SQL, without Postgres or something, can I pull it right from that database from EWS?
Okay. So I've not explored that option yet, but I think it should be possible. If you can sync it to one database, it's possible for it to. Oh, okay. Let me share my screen. So after you authenticate, where you copy your authentication token and you pasted it in your Substreams auth, right? The next thing you now type is Substreams GUI, which will now produce this. Then you press enter to start streaming. GUI. GUI. So, I mean, you can just do PP, OOO to just be like monitoring everything, right? So now that we have been able to like initialize the substreams, now we are going to now sync these substreams into a subgraph, right? So how do we sync it into a subgraph? You go to your Subgraph studio and you create a subgraph. There's a way you look at me whenever I see this subgraph, like I feel like he doesn't buy into subgraphs at all. But then let's go. So now I'm going to go to Subgraph Studio and I'm going to create a project, right? So I'll just go to TheGraph/studio, right? So welcome to /studio. Here, I'm already connected. I've connected my wallet, right? So I could just, I want to delete one of these old ones that I have. I'll delete this old one. Right? So now that I've deleted it, I want to now come back and create a subgraph, right? And for this subgraph that I'm creating, I'll call it what? Simple bank. So, but for this simple bank, I'll select the network as what? I'll select the network as Starknet Sepolia, right? Then you'd see this stuff where we'll load the data. So because we've already done these previous steps, right? This one involving the dev container is the substreams that they want us to implement. So we are just moving straight to the subgraph section, and we are going to try to like initialize the subgraph. So the first thing we are going to do is for us to do this substreams code gen subgraph, right? You do this for it to create the boilerplate of the subgraph code, right? Because in the end, subgraph is just like code. So now, we'll come back to our terminal again. You can just create a new terminal. You can close that stream if you want. So, I'll do code gen subgraph, right? And now we have created a new folder named subgraph, right? If I now cd into it, let me open it here so you guys see it. So inside this our simple bank graph, right? We'll now have a new folder called what? Subgraph. And if we open it, we'll see source, we'll see mappings.ts, we'll see schema.graphql, right? I see that it's empty. It's just type my entity at entity ID. Then in these mappings, we'll just have it, it's also empty like this, right? So now, the first thing we want to do is, let's follow their commands, right? But before we CD into it, right, let's just do one quick authentication. We'll authenticate it, right? We'll authenticate it first. So before we CD into it, we'll do graph auth, right? And we'll authenticate it. So now, this our graph is linked to what? It's linked to this Subgraph Studio here. So now, we can now CD into it. CD into what? Subgraph. Do npm install. I mean, you can choose to use their commands, because their commands are also nice. But what their npm run generate does is that it's running graph code gen and graph build at the same time. Then npm run deploy studio is doing what? Graph deploy, the name of your project, right? So let's look at the schema, because this is where like things are going to get interesting. So this schema is where you define the data type of the event, right? The things you want to query inside the event, right? So after you have created your schema file, you now come to your mapping, and then you now define how it is going to absorb those data. You get? Because whenever you do graph code gen will carry all the schema that you defined in schema.graphql and go to this, inside there's a folder called generated. It will come to that generated, because we have not generated anything, obviously, that's why it's not showing. It will generate it, then inside it will now generate generated/schema. So from here we can now fetch it. We'll now fetch that data, how the data is supposed to look at, then we can now manipulate it inside here. Are we cool with that? So now, let's wait for it to install. So what we'll be doing in our schema now is that we'll come to our contract, right? This is our contract. Or we'll come to our events like this, right? We can see that we have account created events, we have deposit made, we have withdrawal made, transfer made, and account closed, right? So we'll write the type, right? So we can now write type, account created. It's an entity, right? And it's immutable. So we'll do that. Then we can now put the name. The name, what we're going to be expecting is string, right? For the address, we're expecting string. Contract address will also be a string in JavaScript, right? Then for the balance, which is U64, we will now put big int as the data type we're expecting. We'll do the same thing for here. Amount will be what? Big int. Address will be what? String. We'll just repeat the same thing, right? We generated our types. We'll now do graph code gen so that we'll be able to generate that schema. We'll now go to our mappings.cs. What we'll now be expecting from our mappings is that our mappings is going to bring us those data. We'll go through that data, we'll sort it out. We can modify it anyhow we want. Then before we now save that entity, right? Generate an ID for the entity, save the entity, right? So that now when we are querying, we're able to query the data. How many people write backend code here? Backend. So like you understand why you have to create a schema first. And then you also have to do like the whole place where you are sorting what is coming in and how you want to like filter through it. So now, it's still installing. So should we start creating? No, let's chill first. In the meantime, let me check something. Yeah. It's still installing.
But the process is kind of confusing.
It is.
Very confusing. What if I not document my mom miss one step? You go back to A, that's for A.
So in my own view, what I feel is right. If you go through the documentation and because the steps are like easy, these steps now it's something that I did it like 5-10 times, right? And then I now got used to it, and I know that before I move forward, I have to like initialize, build, authenticate, right? Initialize, build, authenticate, generate. Initialize, build, authenticate. Then for subgraphs, you have to initialize, build, authenticate, deploy, right? You are deploying because you are taking it from the state on your laptop to the studio. That will give you an API that you can query. But I get that it's complex. I think I'll write an article that would like detail all the steps by steps.
Okay, I think that would be
Yeah. I'll write an article so that it will be much better.
So but if it's in the index and it's not contact any event to the next step of your backend.
So now, can you see? You remove that backend. There's no need for the backend again. From your indexer, you're just fetching straight to your front end.
So when we now store it, you store the index on your backend.
Yeah, not, so the graph is already okay. You are talking about indexer, not the graph. Yeah. If it's indexer, I mean, you go through that. You send it. Can you see? Send.
You don't need to send your send.
No, they're like 3 send because when you send, then you fetch on your front end again. Think about it now. All those things, that's like 3 milliseconds, 3 milliseconds, 3 milliseconds again. That's like 9 milliseconds compared to 3 millisecond one, 2 millisecond one, 5. Soft. Simple life.
No, you're very hard life.
My screen has stopped sharing. Okay, my screen is still sharing, right? So under the events, I'll just copy all the events, this thing. Come inside my subgraph here. Oh, schema, right? I can just paste it under here so I can be looking at it, right? So for the first one, which is what? Account created, I'll do a type, what? Account created at entity. See the problem with AI, ba? Copilot always, it used to do more than itself. So you can do what? Immutable. True, right? Then you can now come here. So it will now be ID. So this first ID, right? It's taking a data type of ID. So this one is like a default for when you are creating entities in the graph. It's just like if you are, I'll use backend again as another reference. In your backend, there's always UUID, right? Yeah? Oh, that is for us. Normal backend, you'd have to define an ID.
No.
Yeah?
The database will give you the ID by itself.
Okay. See, database is generating the ID for it by itself. For this one, you're the one that will specify the ID. You understand? So the first data type you would always define is what? ID, right? To specify the ID of that particular map, right? Then followed by, so for the name here, which is FEL252, we are using what? String, right? So this apostrophe at the end is to specify that we are not expecting null values, right? We're not expecting null, we're not expecting undefined. We are strict at what we want. Then for address, we'll also put in string, and for balance, it's a big int, right? So I can clear this one. Right. Yes. Okay, this is a Rust-like syntax, right? Okay. So now we'll do type, deposit made, right? Same thing, it's also an entity, right? And for this entity, it's immutable, it's what? True, right? And then we can now, same thing, ID, permit me to copy and paste, because is that not what we all do? Right. Address what? Right. So now we also do for withdrawal made. I'm seeing amount and address, so I can just in this life avoid stress. So we do for transfer made. Also same thing at entity. You see, it's so stressless. It's just that like it can be confusing at first, but like once you get the hang of it. That limitation is a small thing. It's a small challenge.
It's not a small thing.
And I feel like it's because I've not like taken time to look at it properly. I'm pretty sure there is a way around it. But the problem with when you are trying to like ship fast is that you want to just find the fastest way to do things. Right? We've done for transfer made. Then last one is what? It's the subgraph, not the substream. Yes. Because let me show you what I'm talking about, right? We are going to open, I'll show you the file. You guys will look through the file with me so that you guys will see what I saw, right? So we'll do at entity, right? So now, you can do it too. Yes, because I think their code is open source, which means you can go and contribute, and maybe if you're able to create support for like those other data types.
Okay, on this subgraph.
Yeah, sure. I mean, these are, we have OGs here now. Are we? You're not an OG. But all OGs are learning now. Eh? Yeah, Subgraph. Network. You use? Yeah. Subgraph Studio. Oh, use. Okay, it seems you are using an old this thing, ba? Okay. Starknet Sepolia. Okay. I thought maybe it was a command line that was showing that thing. I want to say, maybe this thing is old. Glow, I think Glow would actually have testnet. Or Glow itself is a testnet. So we defined all our types. Can save this. Then we can go and check. I think something is wrong, bro. For this thing to be taking time like this. Yeah, that's what I'll do. Let me see.
Is it due to JavaScript?
Yes. The installation process is taking time. Why? Is it the network? We have speed. Because if it had worked well, So now that we have created our schema, what we're now going to do is the npm generate, right? So let me just open the code so that you guys will read it yourself, so that you guys will understand why they're using the npm run generate, right? Is that their own generate? What's it running?
npm
Code gen and run code to gen. You could also do this with like graph You understand? You can do graph, because look at the code gen, what is it? Graph code gen in the end, right? And this protogen, what it does is that it fetches from, remember I told you of one file. I said of one SPKG file. Sure. Now that let's do npm run generate. The reason why we just do, because we have defined our schema already, right? So when we do npm run generate, it will just go and generate for us the type that we need. So now we can just come back here, and if you come here, you see this generated, and you can see the schema.ts. Are you seeing it? It just has all this like bunch of stuff. So we can now come here to this our mappings.ts, right? I remember our mappings.ts is importing the entities that we've defined from that generated schema, right? So now inside this code, we're going to add something new. Because now we are handling multiple events. So this code, I got it from another project that I'm working on, where what I was trying to do here is, for each of the events, we'll pick a particular event, then we'll now check the description of that event. So we'll get the description of the event, right? Convert all the events into objects. Then we'll now be getting for each of the entity. When we get for the entity, before we'll now save the entity. Do you get? I know you don't get, but don't worry, we'll continue with the code so that as we are going through the code, everybody will understand, right? So, okay. Right. So now, let's come back here, right? And so now, it's almost the same thing we have here, right? So the input, from the input here, the input is getting all the events, right? And we now have a loop that is running through all these events, picking a specific event, right? When we pick a specific event, we'll get the description. If there's no description, it's going to break, then go to like the next thing, right? Then we'll convert that into an object. Then now we'll try to get for each of these entities. So we'll start with this first one, which is what? Account created, right? So now it will be if JSON object dot get what? Account created, right? So inside here now, we can now define, we'll now handle what? We're handling what? Account what? Created event, right? So now, when we've gotten this JSON, we are supposed to import it from the graph, this thing here, right? So now, we'll also have to import what? We also have to import this what? Account created. So we'll also import it too, right?
But I thought that the account created is wrapped inside my entity.
No. It's not wrapped into my entity. You know, if you look at this, our schema, where is our schema? My entity is its own.
Oh, okay.
I can delete this my entity now and will not need it again, right? Because that my entity is the default that it comes with.
Oh.
So if I delete my entity, like this is like a blueprint that we can follow. That's why I left it here. So that now, oh, okay, someone said it's not hearing clearly. Can you hear me? Can you hear me now? Can you hear me? Okay. Let's go. So, where was I? So let me just copy this. Right? So now that we're inside a case where you've gotten the account created object, right? The next thing you want to do is for you to do what? to get an instance of it and convert it to an object. So it will now be const. We can use lowercase account created like this, right? Dot get what? Our account created dot to object, right? And now we can now be getting all the things that are inside, right? So we can now come here, we can now be like const what? Name, right? Will be equals to what? Account created dot get, right? Then we'll now pass in. So you have to be very careful here, right? Because what you are getting now, you are not getting this entity that you define here. You are getting the name that was used in the event. Do you get? Where is that event code again? Okay, yeah, it's still in the same folder. Where am I going to? So we are looking at, let me open the event section again, right? This is what you are getting, this name, this address, right? Don't do the mistake of mistaking it with what you define in your schema, right? So now we are getting name, right? But when we get name, we also want to convert it to what? To a string, like this, right? So we've gotten name and we've converted it to a string. The next thing we also want to get is what? Address. If we get address, what we do, also convert what? Address to what? Right? Then the last one now is what? Is balance, right? So you can do balance as what? So there's a bunch of weird string manipulation that is going to happen here. So let's get balance as a big int, right? We'll do account created dot get what? Balance dot what? To big int, right? Then I'm coming. I just want to get something right. Okay. So now we can now do what? For the main balance itself, it will now be what? Balance will now be equals to what? We'll now do big int, right? Dot from string, right? We'll then typecast this our balance as big int to what? This feels like a cyclic process because like you converted it to big int, then converted it back to string, then converted it back to big int. But when I tried doing it the other way, it kept on throwing errors. That was why I just stuck with this method, right? So now, the next thing we are going to do is for us to generate the ID that we are going to tie our entity to. You understand? And to generate that ID, we are going to use a crypto library. So for that crypto library, we are making use of this crypto.ketchak256, right? Then I'll just copy this whole code here like this, right? And I'll come here and I'll paste it here, right? What happened? Right, so now in this our case, we are doing what? We are creating what? The account created entity, right? And it will now be what? Account created ID, right? Crypto.ketchak256. You guys know ketchak256 now. Yeah. Then we'll get the bytes from the JSON description and convert it to a hex string, right? So now for our underscore, so this will now be like the instance of the account created. We'll now load. We are loading that entity type that we created here, this one, right? We'll load it, then we'll now pass in the ID, right? Which is the ID we just created now, right? If it doesn't exist before, you create a new one. Simple. Right? If it doesn't exist before, you create a new one. That's pretty much what you are doing here, right? So So after we've created the entity, now we now want to assign things to that entity, right? What we can now do is we can now do what? Account created dot what? Dot name would then be equals to what? The name that we created, right? We can now do what? I'll just copy and paste this 3 times so that I can just come here and be replacing it, right? Next one is dot address, and then, oh yeah, I made a mistake. Then last one is what? Dot amount, balance, ba? Right? So now that we've done that, we can now do what? We'll save, right? So I think, let's look at how they did it here. It's entity, blah, blah, blah. Okay, so it's now be what? Underscore account created dot what? Save, right? So we've created our first entity in our mapping, and we could go around creating like the rest, but I want us to deploy this one, right? Let's just see how it looks like, right? So after we've done this, the next thing we are going to do is what you are supposed to do now is you do npm run. You can do graph build, right? Error. Subgraph, blah, 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 dot type. No, it's not assignable. I probably made a mistake somewhere. So, because I did not specify accept a null value, because I did not specify that it should not accept a null value, it threw an error. Let's test for one first. Let's see, the first one did not throw error, that means we are right. Are you seeing? Because I did not specify that apostrophe, I just need to specify that it should not accept a null value. So because when we're defining our schema, we explicitly stated in our schema that what? Do not take a value that is not null, that is null, right? And then in our code now, I'm now passing it just straightforward, saying just take it like that. When I should have explicitly put it in here that what? Make sure it is not null. Make sure it is not null. So now when we do our build, right? It should compile properly, right? It has built. So normally what we are supposed to do is to complete all the mappings. But what I'll do now instead is that I'll deploy this one first so that we'll see that it is working and we'll be able to make queries to it, right? So now let's do that, right? To deploy, let's use their own deploy command, right? Their deploy command here is what? npm run deploy studio, right? So do npm run deploy studio, right? So it will ask you for the label you want to use. In this case, let's use 0.0.1.1. You get? We use v0.1.0.1.1. So sometimes when you are uploading, what did I say? I was about to explain that this error is to happen, right? So sometimes when you are uploading your subgraph, right, it will throw this error. This error failed to upload to IPFS. And that's because the subgraph works with IPFS, right? And sometimes just like I think if you are querying too much, it will now be throwing an error because it's failing to upload it on time. So you might just have to like give it like 1 minute, then this error would solve. Once that's resolved this error, then automatically it would like deploy properly. But in the meantime, we could just try creating the other events and try to handle them, right? So what I do, my method, simple. You always have to go for like the easiest thing in life. So now, we'll handle what? The next event we'll handle is from our mapping is we'll be handling what? Deposit made, right? So we can just do what? Right. Right. Then this one will what? Deposit made. Then we can just like do this, do this, do this, do this, do this. So what deposit what? Right, so right, this one is capital D. Right, so we'll also import deposit made from here, right? But then deposit made has its own things. It's not collecting name and balance, right? It's only collecting what? Amount and address. And the amount and address is collecting is amount is big int and address is a string. So that means I can just come here and replace the one that is a big int with what? Amount, right? And we can leave address, right? We'll cancel name because it's address and amount. So we can come here, remove this name, change this one to what? Amount. The amount is you guys know what happened? I swear. It's crazy. Balance is what? Amount now, but then we'll come here. We'll make this what? Amount, right? Leave address, remove name, right? So now we can come back and try this our deploy before we save that other one. It should work now and we should not be getting error. The thing normally throws errors like this when the queries are like back to back. So once it's successfully adding file to this IPFS, just know that you don't have problem again. But if it's not adding the files properly, that's when you'd be having this error. And this error, you can just, if you copy this HTML code, you'll see that it is just telling you what, try again in a few minutes. Web server reported a bad gateway error. Simple.
According to IPFS.
Yes, so how the graph works is that you upload all these your files, this your schema, all those things, it's uploading into IPFS. Then I'm pretty sure maybe they have like a system where they are reading this data from IPFS. You understand? Because since it's purely decentralized, that means they don't want to make use of any like Web 2 technologies. This thing is going to throw the same error because of this IPFS stuff. And you know, most of these errors, I noticed them when I worked with like these substreams, right? You won't see these errors with like normal subgraphs.
Now the database that Subgraph makes up is IPFS.
Huh?
They made use of IPFS instead of database.
I don't know how that works, but I know that they are making use of IPFS to a certain level because they are storing some key files in IPFS, right? But I'm not sure I don't think they're using IPFS to store their data. I feel like because the graph has nodes, right? So it's possible that they have like a general state in their nodes that they are updating. You understand? Do you know what's happening now? This is why I don't want to use this npm run command. I wanted to use the normal graph deploy, right? Because the normal graph deploy will ask me what's the subgraph name. And I can now put what? Simple. Well, let's even come to our Chrome. Let's look at what we defined our subgraph as. We defined our subgraph as what? Simple bank. Okay, yeah. So I can also what? Let me try it like this. Let's see. Oh, we can use. What's wrong? Right? Let's deploy again. So when you use that their command, I noticed that it took, instead of it, it's coming to this place, slash thegraph.com/deploy/. There is this white space here. Are you seeing the white space? Simple underscore bank. And I noticed this problem, and I feel like, right, that the problem is coming from either the package.json, right, where when you do deploy studio, can you see there is a white space here? And I feel like this is a bug from them, right? Which means, what does this mean? That we can fix it, right? If you go through their rep, no, you can go there and like raise the issue yourself.
And you are able to have space.
Eh?
You are able to have space.
Yes, it's not supposed to have space. So this space alone, it's always breaking the deploy. That's why I just used to use this graph deploy. Like I'm telling you that this error took me a while before I could go to deploy to graph node. It hasn't deployed yet too. And the reason why it hasn't deployed, there's a name something that is going on. Let's try again. In the meantime, let's add more to these our mappings, right? If I save this thing now, it will affect our deploy. I don't want that. I want us to have a deploy with like accounts created first. Then we'll now deploy with like every other one inside. The more you like deploy more graphs for your dApps, the more you begin to enjoy the graph. You're looking like I see you not deploy graph for your dApp. Yes. You're looking like I see you go and do read and write only. But like most, it's not deploying. Don't worry, we're going to fix this now. So how did I even fix this at that time? There was something I just did. Where is it? So I just came and I canceled this. Now we'll do npm run deploy studio. What is the subgraph name? Simple one. This is a naming issue. I feel like there's an inconsistency in the name. That's why I try to maintain, if I'm using one case, I'll maintain that case. But I made that mistake. This is the slug I'm supposed to use. That's why it's in the true level. I'll fix it. If this one fails now, I know that the right thing to do is to use simple bank like this. Still failing. So let's save this. That's IPFS error. So once we solve the IPFS error, let's just wait for it. In the meantime, let's finish all these other mappings. So we have deposit made. So the next one is withdrawal made, transfer made, and account closed. So withdrawal made is the same thing with deposit made. So you can just copy and paste again. You can come here, right? Copy it like this. That was handle withdrawal what made event, right? Withdrawal made. I'm coming. I'll do this deploy again. I'll put simple bank like this. V0.0.1.2 this time. And we can come back here. Right? So this one is what withdrawal made. Right, we can now turn this to withdrawal made. Right. Right. But then, let me add more to the mappings, right? I'll add more to the mappings. So for here, remaining transfer made and account closed, right? So we can now do for transfer made, right? We can do right? So here will be what? Transfer. We'll convert it to an object here. But in transfer made, we are getting amount from and to, right?
Yeah.
So, I mean, this one is easier. We can just replace this with what? From. If we copy and paste it, we'll have to now. Let's look at it again, amount from to. So we already have amount. So we have from to and amount, right? We're supposed to replace this withdrawal made here with what? It's transfer made, right? And then here we can make this what? Notice that I'm using capital letter for like the instance, and for anything that is instant, I'm using small letter. Right, so we've gotten transfer done. Except that here, instead of dot address is what? Dot from equals underscore from. Then we can add for to. Hey, why am I saving? I should not have saved. I need to still have the last save state. I should not have saved it. Right, so let's deploy again. So I was using simple underscore bank, 0.0.1.1. Let's see. It should work this time. Well, I've noticed that problem, they usually have it with IPFS, where if you do like multiple deploys back to back, it will not be like as if this thing, the IPFS node they are using has.
Maybe be a set time frame for you deploy.
So that's, we should set it.
No, I mean maybe
Them, yeah. So yeah, it's possible. Yeah.
Not deploy continuously.
So that to avoid problem. It's even still throwing the same error. But once it's able to go through, because we even need, so that we'll be sure that we're even going to push to our subgraph. Because, let me look at the subgraph command. Then they just said write graph deploy simple bank. So let's just finish with the last mapping. Since it's here to deploy, we can just do for the last mapping. So for the last mapping now, we are handling account closed. Right, we'll be getting what? Account closed here. Same thing, right? Okay. So let's just replace this with account closed and account closed here. Then, so now, I mean, the next thing we want to do is to do this, turn this to account closed. See? right? And what account closed, right? Now that we've gotten that, we now want to make sure that it aligns properly with the stuff that we have, which is closed, beneficiary, and amount. I mean, what we could do, which is an easier way, always look for the easier way. Oh, no, that will not make sense. We'll just do like this, right? It's what? Here it's not from, it's closed. So we'll replace this what? Closed. And replace this from closed, right? Then for all the tools, we'll replace them with what? Beneficiary. Yep, so the last thing we have to do is to import it from our schema, like this. And I hope this thing will deploy now, because, no, I'm not going to do it this way. I'll do it the way they told us to do it here, which is to just graph deploy simple bank. So this thing should just upload, because somebody's already sleeping, sir. Why is it showing that error? Why is it showing that error? HTTP waiting. And at the last step be that. That's the last step. It to be from that name. I'm just sure. Okay. So this one did. So that means I should have done graph deploy simple bank since, instead of all those upside down waka. So now let's come and see, and you can see it as synced, right? So you can come to your playground here, and we can see it. So by default, it's the one that adds this extra S. Are you seeing this extra S? So when we query it like this, are you seeing? You can see how fast our data is coming. Yeah. ID, name, address, balance. ID, name, address, balance. That's for, so I mean I could play around with these queries. I can remove deposit made so that it will only be account created, right? And then we have this data, right? I could also play around. So the reason why this their playground is good now is that if you don't know GraphQL queries, if you don't know how to write it, you can come here and you can edit it. You can edit it to like first 3 or first 2. You can say, can add where cases. Where address is this. Where address contains this. Where amount balance is less than or equals to, like this one. Balance is greater than or equals to. Balance in this. Balance not this. Balance not in. All these things are like, because normally if you're writing your SQL queries, you write SQL now. So you know all those where, you know all those, if this is this, do this, if this is this, do this, right? They just have like a bunch of queries. And the documentation also provides like ways for you to be able to now do, you can now do, what do they call these things in backend, where you'd have 2 schemas that are dependent on each other, right? You can now link them up. You'll now be like, oh, this one should update this one if this one is this, right? You can now create all those kind of things. And you can create really complex data structures from just your events alone. Which means, to me, I just feel like the graph is awesome. Like, it's not because of U256, which I feel like we'll be able to sort out. So let me, because you know we made in this, one last changes in this mapping. We can just save it, then we'll deploy again. By the time we deploy again, it's automatically. But note that anytime you change your schema, you have to do code gen, right? Anytime you change your schema, you have to do code gen so that to generate the types, right? So if you come up here, you see entity count. It's showing 20. That's like total entities that it has gotten, right? Then you'd ask yourself, how will you integrate it into your front end? For you to integrate it into your front end, if you come over to details here, to endpoints here, there are different ways you can, for React apps, you set it up this way. And it's just for you to be copying and pasting and be changing the query here, right? You change the query based on the query you've created in your playground. Then, same way you'd create a wrapper. Before it used to be Apollo client provider, but now I'm seeing query client provider, right? So there's also the listing for Next.js and for Node. So if it's a backend stuff that you're doing, right, you would also do it like this. And so let's deploy the last deploy. Then I'll push this subgraph code to the repo, right? If you're pushing the subgraph code to the repo, something you should be wary of. This target file here, this replay file, it's very heavy. It's like 250 MB. So don't do mistake of adding it. You could just put it in your git ignore, right? Or you can delete it. Right, so I'll push the last one. I'll deploy the last one, right? I'll just graph deploy simple bank. See how just graph deploy simple bank I was using. So anytime you want to deploy, you have to change the label, right? So now it's going to be let's just use 1.4. And the moment you deploy, it's so instant that by the time you move our mouse to go to that Subgraph Studio, you see that it's already in 1.4 already. It's the speed for me. The speed is crazy. Yeah.
No, not
So now you see we are up to 0.0.1.4. So now the thing is, by the time if we do another deploy now, it will archive 0.0.1.3, right? Can you see a few seconds ago? This is crazy. I'm bullish on what people are going to build with the graph.
But sorry,
Yeah.
just a little observation.
Yeah.
Now the simple graph now works on events.
Yes.
Now I just need a new tab now, not tested it.
Mm-hmm.
I will get the event.
Yes. So you'd want to test out your app by calling all those functions. So anytime you call function, you can come and check it out here now.
I think the way you call the function to get to the front end.
Yes.
Test it.
Yes. So now the last subgraph class we did the smart contract. We built the front end. We interacted with it before we now created the event, the subgraph. Then we now fed from that subgraph to that front end back again. Do you get?
Okay, now you have to connect your front end for them to test it.
Yeah,
Now,
that's one way.
The last part of the graph.
Yeah. If you want to take it that way. But you could create your smart contract and create your subgraph immediately after, right? You just have it on standby, waiting for when. But now the problem is, what if you change something in your smart contract and you redeploy? So that will now be another problem, right? So we'll be rounding up, and I'll create an article that would describe all the steps involved, and maybe we would also, in the article, we'll deploy a smart contract, create the front end, link it up together, and just all the steps, so that it's easy for you to replicate it on your own. And
Okay, so when will be the article be available tomorrow?
no, not tomorrow, maybe next week.
Oh.
Next week. Yes. So thank you very much.